What's up? Welcome back. In this episode, you'll see how to solve day 9 of the Advent of Code for 2022 in Ruby. And today's problem is called rope bridge. It reminds me a lot of Snake. In today's exercise, what we get is a series of moves. So this is our input. We're going to be told, okay, we're going to move right 4, up 4, left 3, down 1, right 4, etc. And we need to move the head of some rope and have the tail of the rope follow it as if it was a knot that was behind the rope. And then when we get to the second part of today's challenge, it's going to be more than just the head and tail, but we're going to start off with just moving the head and a single knot right behind the head. And one thing that's interesting about the way that we're moving is that the head is always going to move left, right, up, or down, but the tail could potentially be diagonal. And if we are in a situation where the head is diagonally in a different row, a different column than the tail, then the tail is going to make a diagonal step to catch up to where the head is. All right, let's grab our example input. We'll create a new file here, and we're going to drop this, as always, at the end of our file. Because a lot of this movement can go awry, again, I really want to just include rspec and write some tests. So we're going to say rspec.describe, and we're going to say like it parses input as expected. And so here we're just going to say before all do, and we're going to say that moves is going to be data.readlines. And now we're going to make some method that takes in our moves, and that's going to give us back basically like what we got down here. So we want these to be broken up as letters and integers in their own arrays. So we're just going to say, all right, so this is what we should get back from some parse moves methods. So we'll run Ruby day 9. And we get back an error that says we don't have this parse moves method. So let's go implement that. So we're going to say parse moves takes in some input, say input dot map chomp dot map, and then we want to split on space, and then we're going to map, and yeah, we want the integer version. So let's see if this works. Okay. Oh, wait, we don't need to convert the first one to integer. We just want to convert the second one to integer. Okay, cool. We've got a passing test. So that should parse our moves out into the expected format. Now let's make it so that we can test some logic for making a single move where we're going to move the head in some direction. So like it moves the head. So we'll make some method called move that's going to take in, I don't know, some array. We'll start at 0, 0 to make it easy, and then it'll take some direction. So let's say we want to go up 1, and we're going to expect that that's going to give us back a new array where it has moved up 1 row. So we'll run this test, and there's no method move. Okay. So we're going to take in some piece or something, and then we want to say we're going to get a direction, and we're going to get a distance. And I don't think this is actually what we want, because we need to use up, down, left, right instead of north, south, east, west. So I'm actually going to do something different here. So we'll say like when the direction is up, we want to say head at 1 plus equals 1, right? And then if we're going down, east is left and west is right. And so then we're going to say, yeah, if we go down, we want to go down. And then if we're going left, yep, that's correct. Okay. So now what we should get back is our new location for head. And oh, so here we need this. Okay. All right. So now we have 2 passing tests. We're able to at least like move the head around. Now what I want to do is potentially pass in some more details to this move method so that we can also track where the tail is going. Okay, so we have a test here for up, but let's also make one for down, left, and right. And instead of just 1, let's make this 5, just so that we can get some more interesting numbers here. So that's going to go 5, and this should be like -5, right? And then in this case, if we're going to the left, we should have -5. If we're going to the right, we should have 5, and we're not moving rows or columns yet. Okay, So at this point, we're not actually working correctly. And I'm glad we modified our test because this distance now needs to be executed several times. We're going to say distance dot times do, and then we want to like modify the head and ultimately return the head. The reason we're doing it distance times here instead of incrementing by the distance is that every single time we move the head, we also want to move the tail. So down inside of here, like while we're making steps, as we're stepping through with the head, we also want to like move the tail. So let's make a new method called follow here. And we're going to pass in the head and we'll also pass in some tail. So now at this point, it kind of makes sense to pass in maybe the head and the tail both as arguments to move. And so here we'll add a new array to all of these positions. So that is going to represent our tail. And instead of just returning the head, I think we want to return the head and the tail, okay, as an array. So we're going to get back the same value for the head, and then we should get back 0 and 1 less for the tail. Okay. So the tail should follow, except it should be sort of like 1 behind in all of the same directions. Okay. So if we run this test, now we don't have a method follow. So let's make a new method follow head and tail. And the follow method should be something, this is where it gets a little bit interesting because if we're going in the same direction, so in the easy case here, for instance, if we're going to the right, the head moves to the right and then the tail just moves to the right. If we're going down, right, the head moves down and then the tail follows right behind it. So we can implement those first. So we'll say something like if the head at 0 minus tail at 0, if the absolute value of those two things is greater than 1, then we want to move. We want to move the tail. So then we want to move the tail's 0 to something like, well, we want to follow the head. And so this is where we can start talking about the spaceship operator. So here we want to move the head, like head, spaceship operator, tail. Before we go too far, let's crack open IRB and look at the spaceship operator. So we have A. Let's say that A is equal to 5 and B is equal to 1000. So the spaceship operator or the comparison operator is this thing. It looks like this. It's like less than, equal to, greater than, and you can pass, this is a method that we're calling on A, passing in B, and we will get back a value that is either 1, 0, or -1. And this is called three-way comparison. It gives you sort of like, if you pass in A and B, then you'll either get a result that tells you A is less than B, A is equal to B, or A is greater than B. This is based on the law of trichotomy. So every number should be either negative, positive, or 0. And so in Ruby, what we can do is we can pass in these arguments. And so in this case, A is less than B. And then when we call the comparator operator, we're going to get back -1 because we would sort of, the way that I like to think about this is like we would need to move B backwards to get closer to A. And similarly, if we see B comparator operator, spaceship operator thing 1, we would need to make A bigger. We would need to increase A to get it closer to B. So this operator here is going to tell us which direction the head or the tail needs to move. So because we're only moving 1, we know that we want to go either, we want to go up by 1 or we want to go down by 1. So this is going to be either 1 or -1 in the case that the difference or the delta here is greater than 1. Okay. We want to do the same thing for head at 1. Okay. And let's see if so our tests are passing now. For it moves the head, I guess and tail in one direction. And let's add another test here that works for diagonals. So let's say that the head is going to start if the head is at 1, 1 and the tail's at 0, 0, and we move the head up, then the tail needs to move diagonally to join it and be like right behind it. So let's say that we're just going to move these all 1 step. And so in this case, we're going to get 1, 2, and here we should get 1, 1, because the tail should follow exactly into the place where it was before. Okay, so if we're going to go down, let's say that we actually want to start with 0 or 1, -1, and we want to move down. So that should make this -1, -2. And we want our tail to follow in its place to -1, -1. All right, if we're moving to the left, then we can be at or -1, 1. And when we move left, we should end up at -2, 1. Or the tail should end up at -1, 1. Now, if we're moving to the right and we start at 1, 1, move to the right, 2, 1, right? It's going to move to the right. Yeah. Okay. I think that's right. Let's see. Okay. So now what we need to do is we need to update our follow method so that it first checks if the head and tail are on different rows and columns. So if head at 0 does not equal tail at 0 and head at 1 does not equal tail at 1, that means they're on different columns. And that means that we need to do like sort of a catch up in the diagonal direction. We also need to check to make sure that they're at least 2 apart in one case or another. So then we have to do the same sort of absolute value check here. So we're going to do that or head at 1. Yeah. Okay. So we have this absolute value check. All right. Let's just put these all onto different lines here. And so if that's the case, then we want to do both. For the tail, we want to move it in both directions, right? So we need to go diagonal up and to the left or up and to the right. So let's see if our test passes. Boom. Okay, we've got a passing test. So now what we should be able to do is just like call move several times and move our head and tail around. So let's say it works for the example case. So we're going to say something like at moves.each do move. And for each move, we want to call move, or we're going to get back head and tail from, we want to call this M, or I guess we want to split out M into like direction and distance. And we want to move the, head, tail, direction, and distance. And we need to create a head at 0, 0, and we need to create a tail at 0, 0. And at the end of this, right. Okay. So the problem wants us to keep track of where the tail has visited. So as the tail is moving around the board, we need to keep track of where it's visited. And so in order to do that, I think we also need some other new concept called visited, which can be a set of all the places that the tail has seen. So we need to require the set gem, and we're going to use this set class as part of move. So we need to pass in visited and into the move method. And so now we have visited here. And every time we follow, we need to put in tail.do. That's like where the tail's been. Okay, so now we need to update all of our move methods, set.new, and we can just reuse the same variable here because we're not going to make any expectations about it. All right, let's see how that works. Okay, distance times for nil class. Okay, so, all right, we need to parse our moves. Parse moves of moves. And then we should execute this again. Boom. Okay, we have a passing test. And now we want to just p visited.length. And we should get back 13. Okay, so 13 is the answer for part 1. Or I mean, we could actually write an expectation about this, like expect that visited.length to equal 13. And that'll be grand. That'll be grand. Okay, fantastic. Now what we want to do is run it against our input, our puzzle input. So there's this giant puzzle input here. So let's go to day 9 and make an input, and we'll paste that in. And now what we're going to do is we only want to do this rspec stuff if argv.empty. Otherwise, we're going to read in the moves. So moves is going to be parse moves of file.readlines argv.0 or first. And now we can say moves that each do direction and distance. And we want to make our moves. And then we're going to put visited.length. And we need some visited set. Oh, we need a head and a tail. Okay, 6,023. 6,023 was the puzzle answer. Fantastic. Okay. All right. So what we've got now is we are keeping track of all the places the tail has visited. We have our head and tail. We're calling parse moves to get back all the different directions and distances. Then we're calling move, passing in visited, our head, tail, direction, and distance. And we get back the head and tail each time. And then we are printing out where the tail has been. So that is the solution for part one. Part two is the way that we're going to increase the complexity is that instead of just one tail, we have 9 knots in the tail. So now as the head is moving around, it's being followed by the first closest knot, the second closest knot, third, fourth, etc., until there is some ninth knot. And there's a second sort of example here that gives you this bigger initial state so that as H is moving around or as the head is moving around, you can sort of see the tail follow it with a little bit more detail. And this is where it starts to really feel like Snake, right? Where like the head of the snake is sort of swimming around in this grid. So for this example, it visited 36 positions. So the problem is that right now, the way that we've set this up is we only have 2 knots and we just have the head and the tail. And the only difference is that as we're moving the head around and when we're ready to follow the head with the tail, what I think we want to do is not only follow the head with the tail, but we want to follow each knot with the next knot. So we want to iterate over all of the different pieces of the rope in pairs and make sure that we're going to move the head and then we're going to like go through all of the pairs of the chain or of the rope and then make sure that we're moving those. So in order to make this refactoring, the first thing that I want to do is go through our tests. And instead of passing in an array for the head and an array for the tail, I'm going to combine those into one thing and we'll just call it rope. So we'll say, okay, we're going to pass in this rope here and this rope there, and that we're still getting back an array of arrays. That's exactly what we want. So we'll still continue to like receive back a copy of the rope from the move method. It's just that we're like making this a little bit better by passing in the full rope so that we can iterate over all of the different pieces. So here in our example, we need to pass head and tail together. And then down here, we would need to pass head and tail together. In fact, I'm just going to call this rope down here, and we'll make a new thing here called rope, which is going to be an array that is too long, and it starts with 2 zeros. Okay, so now our code should continue to work, I believe. Maybe? No. Okay, so moves. So our move method here now just needs to take in rope. And we still need head, and that, I think that should, well, okay, so now tail is an array. So we actually want this visited tracking to be something like rope.last.dupe. And let's see how we're doing here. Okay, right. Okay, so now tail is an array. So instead of passing in tail here, we need to go through like rope.each do not. And we need to follow, well, actually, in fact, it's like each cons of 2. So each consecutive 2 knots in the rope, we want to pass in like the head and tail of of that sort of subsection. And then we want to return the rope at the end. Let's see. All right, so we're getting the right answer for our input and our tests are still passing. So what this refactoring did, in fact, like I don't think we need this tail here. Like I think we can get rid of that, but because we're not using it anywhere. But for now, we'll keep that so that we can correctly extract and then modify the head. And what we can do now is instead of having our rope be 2 long, we want our rope to be like 9 long or 10 long. I think it's 10 because it'll have the head plus the 9 that are going to follow. And then this is going to be rope. Okay, so let's see. day 9 input. Okay, 25,033 was the puzzle answer. So the small, like the slight modification was just switching so that instead of just following one head and tail, now we're iterating over all of the pairs and following those. So this was a pretty fun little project. This comparator operator, if you haven't seen it or used it with Ruby before, go check that out. It's actually in lots of different languages. So that can be handy if you need to know the sort order of something is common, or if you need to know if something is less than, greater than, or zero. It can be useful in the little trick of like, which direction are you going? I thought about maybe instead of modifying the head directly and modifying the tail as we were kind of like working through it, I thought about trying to make it immutable so that you kind of like had these fixed objects that were being passed around. But I decided against it. It's just a little easier to modify the underlying things. So yeah, this was kind of a fun one. Hopefully that was useful. And yeah, thanks so much for watching and thanks for your time and attention. We'll see you in the next one. Cheers.